name is Aryan, behind the camera is David, and we're really excited to present to you our ECE 243 project. This year we decided to do something a little bit different. Instead of making a game on the VGA, we decided to actually make a full entire robot. Everything about this robot was done from us, from the software to the electrical system to the mechanical design. Looking at the mechanical design, everything was 3D printed and designed by ourselves. We designed this in SolidWorks and we 3D printed it using a Prusa Mark IV 3D printer. The first stepper motor is being housed in this casing over here. The second stepper motor is right here. And if you want to turn around, you can see the third stepper motor is back here. So this is a 3 degree of freedom robot. And if you zoom over here, you can see that this front end is actually detachable. And we have other attachments that we've designed that can be replaced with this component. And so, yeah, we're super happy with how this came out. There were a ton of issues 3D printing it at first, but with enough tries, everything ended up working. Moving to the electrical system, we have all of these stepper motor drivers being powered by this cable, which is actually plugged all the way into the wall. This is a 240 volt to 24 volts converter. So now we have 24 volts on this power rail of the breadboard, and this 24 volts is what's actually powering the stepper motors. The 5 volt rail on this side is being taken from the FPGA, and that gives us 5 volts, which is used for the logic of the stepper motor drivers. The stepper motor drivers that we used were the A4988, if I remember, and we've all tuned these properly to the correct current limits. The step and direction is actually being controlled by the GPIO pins of the DE1-SoC. We're using the NIOS 2 processor on the DE1-SoC to control this, and it is all controlled by these 6 switches. And 2 switches control one motor. One switch, when it's on, controls clockwise movement, and the next switch, when it turns on, controls counterclockwise movement. And the way these switches control the stepper motors is through the software, where it handles sort of the user's inputs, and it senses, oh, a switch has been pressed, which switch hasn't been pressed, and as long as that switch is being pressed, we send a square wave, so it's a sequence of on and offs to the stepper motor driver, and that stepper motor driver handles this square wave that we're sending it, and then converts it into basically a language that these stepper motors can understand. And it basically takes that 24 volts that we're giving it, and then it sends a signal to the stepper motors to fully control it. Another thing we're doing in software is also basically sensing and counting the amount of steps that the stepper motors are taking, because stepper motors are really precise, and we're using a geared stepper motor that's actually a 5-to-1 gear ratio. So instead of a 1.8 degree angle per step, it's a 1.8 divided by 5 step angle. And so we're able to basically count how many steps we are incrementing this motor by, and then based on the angle or the amount of steps we can take, we can figure out, what's the angle that it's traveled, and then based on that, we can actually limit the range of the motors so that, the robot doesn't just keep spinning and then it just breaks itself entirely. So implementing joint limits, basically counting the amount of steps our stepper motors are taking, I think that was pretty clever. Let me give you a quick demo. So the first 2 switches control the rotational component of the robot. So this motor right here, and you can see it spinning right over there. And then the second 2 switches control this first arm over here. we dropped the cup. And then the last two switches control this stepper motor right here. Here, I'll show the camera right here. And this is able to control this arm right here. Just like that. Anyways, we are... Here's a quick demo of our joint limits. Goes 180 degrees and stops, and then it goes back to its home position, and then it goes another 180 degrees and stops, and then we can return it back to our home position. And then we can test the top arm that also has joint limits. And it also goes the other way, and it stops right before it hits the rest of the robot to prevent itself from breaking itself. This motor also has joint limits, and you can see how everything kind of works together.